Welcome back. From the beginning, I noted that there are two main domains of statistics: descriptive statistics and inferential statistics. Up to this point, we have been talking about descriptive statistics, in which we're describing a set of people or a sample that I have. Today, we're briefly going to start talking about the concept of inferential statistics, which will formalize much more in the lectures to come. Any time that I collect data, it's important to spend time describing the data and responses. This gives you a sense of who is in your data set and how they responded to the questions. Now, when I collect a set of data, I can think of this as a sample which is collected from a larger population. A population refers to the full set of people that you are interested in. Depending on your research question, who that population refers to is going to change. And so at times it might be very large. For instance, if I want to generalize to people living in Australia, then my population would be everyone living in Australia. Other times, we might have a very small population. So for example, if I want to say something about staff members that work at Melbourne Graduate School of Education, that's clearly going to be much smaller than everyone living in Australia. What the population is determined by you. Who is it that you are interested in saying something about? Think for a moment about what some populations are that you might want to study. If my population is small, such as the number of people who work in my building, then I really could measure and describe everyone within my population. So if it were small, then I could just collect some data, and the descriptive statistics are really all that I need. However, when usually I'm not interested in just describing a sample, usually I want to use that sample to say something about a larger population. The whole reason I do a study is not because I want to understand just how a small group responds, but I want to say something about people more generally. For example, some of my research has focused on mortality risk, looking at different predictors of this. With a sample, I can look at how long people lived and perhaps some things that impacted or correlated with those who lived longer versus those who died sooner. But the reason why I do this is not simply to understand this group of people. Usually it's because I want to apply that knowledge to people who are still living. So for example, some of my work has seen that physical activity is correlated with longer life. And so I want to use this to say that perhaps becoming active or staying active can be a healthy thing that might even help you live longer. So I do a study with a sample, but I want to say something about a population. It would be oftentimes impractical to measure everyone within a population. Imagine trying to ask billions of people to complete a survey. That's probably not something that you could actually do in your lifetime. This is the very purpose of inferential statistics. It lets me collect data from a sample and then infer things about a larger population using the concept of probability. Let's look at this a bit visually. Imagine that this circle represents the population of people, and the different shapes and colors indicate different people. When I collect data, some of these people will end up in my sample, and some might better represent the population than others. I could collect a second sample, and that would be an additional part of the population. So putting these together, as I collect more and more samples, it would start to represent the entire population. Now, if I look at these two samples here, we see that one of them actually seems to be a pretty good representation of the overall population. There's a good mix of colors and shapes. The second one is less representative. It's mostly the triangles and not so much of the others. And so this brings up a very important point about who we choose to include in our study. How much the sample represents the larger population depends a lot on who I ask to be in my study. And so who is there is going to say something about who I can generalize findings to. Say, for example, I want to say something about Australians. I could go to an undergraduate class of psychology students and have them complete a survey. Or I could randomly sample people from all over Australia. Which one do you think would be a better representation of the country as a whole? Clearly, the random sample of people from all over is probably going to be a little bit better representation of things. So at different times, we might collect different sets of or different types of people or different groups depending on my purposes. And there's a few ways that we can do this. A random sample is one that is truly random. I have access to everyone in the population, and I randomly pick people to be in my sample. So taking the whole country of Australia, I might randomly select people from all over the country and have them complete the measures. Something we use a lot in our studies is something called a convenience sample. We include people in our studies who I have access to and are willing to complete a survey. For example, a lot of psychology research has been done on U.S. college students, freshmen and sophomores, at these more elite universities. And oftentimes people will try to generalize these findings to people in general across the world. Now we can ask the question of whether these university students are really representative of Aboriginals living in Australia or even older individuals who are at a very different life stage. We can also use what's called a stratified sample, in which case we create layers or strata based on a certain criteria. For example, I might select 10 people within each of 5 age groups so that I get a sampling across those different areas. So we can have different types of sampling techniques, and a lot of it just depends on both the purposes of my studies and how much we want to generalize. It also matters how many people are in my sample. More is often better because it often captures more of the diversity of the population. But not always. It could still end up you have a large sample who still just represents a very small group of people. So this is one reason why it's important to spend time describing your sample before you actually do anything else. Because it tells you, how representative the sample is and indicates how big or small the claims are that you can make. When you read articles, I'd also challenge you to take a look at the sample. Be wary of articles that claim that they've proven something when it's a very select sample. So be careful of that as you read. A key takeaway is that the statistics alone cannot actually tell me how valid the results are, who I can actually generalize to. You alone as a researcher or a reader should think through the claims based on who is included in the study. Next time, we'll look at how we can start to use samples to infer about larger populations. Thanks for listening. See you next time.